Hi guys, this is the day 2 of our advanced programming class. So in this class we will see mainly about nodes, okay? Creating a node, adding a node. So what is node? How do we create the structure for that? All these things we will see. Now first we will understand, first of all, what is a class and how do you create an object. All the things we'll see. And where object is created, I hope you should already know by now that objects are present in heap, right? So if I write something like this, right, imagine I have a class, maybe let's say I have a class dog, and if I write here int dogs cost, I'll write like this, dog cost, then I will tell string name, okay, yes, this is what I'll write, that's it. And if I close the class, this class dog is over, okay. So whatever you write should be within a class. Why? Because in real life also everything you see belongs to some class. For example, I belong to a class called as human, this belongs to a class called as table, right? Like that only in real world, whatever you see, everything belongs to some class. It should be belonging to some class. There is no a thing which is excluding a class. That is why in programming also I want to write this, but whatever you want to write, where you have to write, within. So whatever you write, it should be within a class, okay. Now, how do I create an object of this? Okay, before going to nodes, before going to linked list, please we have to understand this. Now, in Java, you have to tell new keyword. When you tell new keyword, what happens is in the heap, right? This is my heap. Inside the heap memory, one new object is about to be allocated. It is about to be allocated, but it can't allocate complete heap, or it can't allocate a little memory. It should allocate sufficient memory. That is why I have to tell one more thing, that is how much memory I want is go to the dog class and scan the dog class, I will tell. So what happens now is whatever is in dog class, cost will be coming here, default values will be added, and name will be coming here inside this object. Default value of string is null. These things will happen. Okay, this is what happens when you create a new dog. But not only that, new dog means new object you are creating. New object, what you are creating, it has an address. I will tell it as 1000. That address has to be stored somewhere, or else garbage collector will collect that. Agree? That is why I have to store the address. That's why I will tell give its address to a variable d. Variable d of what type? Of this object is of what type? Dog type. So I have to tell dog d is equal to new dog. Now what happens is d will be pointing to that address 1000 like this. But where is d? The local variables are in the stack. Local variables are in the stack. So I hope you are able to understand the diagram here. So this is what happens when you create a new dog object. Okay. Now I want to change this cost. If I want to change the cost, if I want to reach this cost, through what I have to reach? I have to reach from in the d, make a dot, I will tell, d dot cost. So I'll tell 100 rupees. Where should this 100 be stored? 100 should be stored in d dot cost. If I tell like this, 0 is removed and 100 will be coming here. Okay. Now next I will tell the string Rocky. Okay, string Rocky, where I have to store? In d dot name. This is what I'll tell. So here Rocky will come and sit. This is how it is. Okay. So I hope and I believe that if you are coming for this advanced programming class, this much of Java you should know. Okay. How do we create an object and how do I change the values inside an object? Okay. Now please let's understand now. I want to create a single linked list. Okay, single linked list, which means it has only the next node. Now what is this linked list? Okay, let's understand that first. What is linked list? See, what happens is, previously there was a problem. That is, imagine that this was your memory, right? This was your memory, and continuous memory allocations were there like this. Let's try to understand that. I want to store what? Hello. Okay, so I will store HELLO in the memory. Then I want to store Dheeraj, DHEERAJ is stored in the memory like this. Okay. Then what happens is, I want to store something, a different program will allocate this memory now. Okay, DK60, a different program will use this memory. One more different program, it will use this memory, HAI, like this. Now what happens is, I want to okay, let's use some more memories. So some more memories are used here. Okay, so I will erase this. Okay, now I want to store I want to store umbrella. Now if I want to store umbrella, now what will happen is, U is stored here. Okay, MBRE, right? RE, but where is LLA, right? LLA is not stored. So that is a problem here. Okay, so in the previous days this was a problem. Why? Because since randomly different program occupies different memory, in between free memory was there, but we can't use it now, those free memories, right? We can't use those free memories. I hope you have understood the problem. Okay, now how do we use that properly? I will tell you. Okay, how to use them properly is by the help of linked list. Imagine that you had a memory like this. So these are the addresses of the memory. Okay, this location is 1, 2, 3 and so on. Now let's imagine some of the memories are occupied like this. Okay, some of the memories are occupied. Okay, okay, so wherever lines you are seeing, those are the occupied memories. Okay, let it be like this. So I want to store Dheeraj now. I want to store Dheeraj. So you can see somewhere else there is a free space, somewhere else there is a free space, and so on. So what will this linked list do? The working of this is like this. That is, it will store the D here. It will store this D, but it will store the H here. Okay, it will store this H here. But where is the next character present? That is mentioned here in the number. Okay, so the character is D, but where will I find the next character is stored in the number 4. What's the meaning of 4? Next I have to come to this location. There you will get the next character, DH. And here I have to mention where is the next character which I will get. I will store E here. Okay, so that is in the 12. So I'll write 12 here. Means it will use this H. Then there only we have one more information. So 2 information we have. Where is the next pointing to, right? So it is pointing to 12. So it will point here like this. But this here, here I have to write E, and the next character is in the 14th location. That is E. R, where R is stored? In the 70th location. So R is stored here. A, where is A stored? A is stored here. That is in the 26th location. So after reading R, it knows where to go. Direct it will come to 26. Okay. So in 26 there is A, but the last character J is present in 33. So it will tell 33. Okay. So this J, and after J, what is there? After J, is there any other character? No, right? So how do we tell something? By telling null. Null means what? Whenever null comes, it means that your string has ended, or whatever your name, your object is ended. Okay, but see, I have to come to 4. Okay, who has told come to 33? This person has told come to 33. Who has told come to 26? This person has told come to 26. Who has told come to 17? From here I got the information, come to 17. Agree? Who has told come to 4 or okay, this is 14, right? So who has told come to 14? This person has told. Who has told come to 12? I got the 12 information from here. Who has told that your memory is there in the 4th index? This object has told. Means, don't you think I have to come to 2 first? If I have to come to 2, yes, out of your memory, okay, this memory I have to store in the one variable okay, location, that 2 I have to store. So from where I have to start, so from where I have to start, you have to start from the second, memory number 2. I should have that starting point. Once I have the starting point, okay, I have to start from 2, then I will come here to 2, then I will get the next address 4, then I will get the next address 12, like this. So this is only that linked list. I hope you are able to notice, like this. See, can you see link is there? Yes, this is only our linked list. If you want, you can pause the screen and take a beautiful notes of this. Okay, now, so how we are planning to do is like this. Okay, so definitely I need one object here, right? I need an object where first of all I want to store the data. So I'll store the number 10. This is the data part. But I want to store one more data, 20. But between these two I have to do a linking, right? So I have to make in such a way that this will point to this object. So this is how I have to do. So how to do that? Let's see. So imagine I have to create what? 2 nodes, right? I have to create 2 nodes. So how do I create a node? By telling new class name, new node I will tell. If I tell new node, okay, what will happen? A new object is created. Agree? Yes. So now I will create one more new node. Okay, I will create one more new node. So let me do that here. New node and new node. So 2 new node I have created. New node here and new node here. Let's imagine, for the example's sake, for this node it is 10, it is 20, and each and every node will have an address. So this node I will have the address as 1000. This node I will have the address as 2000. Okay. So now what I will do is I will tell this 2000. It has to be stored here. This is what I will tell. So now what will our computer understand is like this. Okay, I got the value, but if I want to get the next value 20, yes, I have to go to this memory and it will search that memory, it will find it 2000. Okay, and in 2000 it will print the data of it. It is 20. But where will I find 30? Right? Where will I find 30? 30 is present in 3000th index. So that 3000 I will store here. So that as soon as it prints a 20, it knows to get 30 to which address it has to go. It has to go to 3000 address. So this is what it is. Okay. Now, first of all, let me talk about this dog class, right? Let me talk about dog class because it is not completed. Okay. So now this is the way, right? Can you see? This is the way to update a dog's property. Yes. So first of all, what I have to do? I have to do many tasks here. First of all, I have to create a dog object. After creating dog object, what is its cost? What is its name? Separately, I have to add. Now, don't think separately adding is expanding my code. Yes, it is expanding my code. So how can I create a dog object, give its cost and give its name? How can I do these 3 things at a time? Is like this. You have to, okay, you want to do all these things at once, then you have to tell like this, you need a new dog object. Okay, you have to write like this, you need a new dog object. What? Dog object. But don't write simply like this because it will only create a dog object. But what you want is you want to give 100 to the cost and Rocky, right? Rocky as a name. See, this whole thing can be written like this. You have an option. Either you create a dog object, give the cost and give the name separately, right? How many lines are there? 3 lines, 3 lines. Or these 3 lines can be reduced such a way that new dog, you told you one dog object and you're passing the values also. What is the cost? What is the name? Don't you think this is much simpler? Yes, this is called as parameterized constructor, and I hope that you know about this also. You should know about constructors, basic programming. Okay, so what we will do is, yes, we can write like this, right? But you know that if you're writing a constructor, you have to write the rules of constructor. Okay, now let's leave all that. Now we are talking about node. So what I'll do is, since definitely, don't you think if I'm writing node here, the class name is node? Yes, class name can be anything. Okay, it's your wish. Let me write, there is a class called as node. Okay, This is not an inbuilt class, this is just a name, class node. I'll open the class. Tell me each and every object, okay? Don't you think each and every object, whatever you are seeing, it has two property? First is the data property, right? First is the data, what data it should hold, and one more is the where it should point next, that address it should store. Agree? So we need two properties here. One property is data property. So inside the class node, what I'll tell is the first property is int data. I want to store data. Not only data, okay? Inside an object, I don't want to only store 10, but I want to store the address. I want to store. Address of what? One more object. I want to show the address of one more object. Yes or no? I want to show the address of one more object. So where this next is pointing, that also I want. But data is of integer type. Can you tell me this is of what type? You are seeing a 2000 is of integer type, but please understand 2000 is not an integer. For representation purpose I have written 2000. But in actually address is not a number. Is it clear? You can't store it in integer. So what type it should be? It is like this. Imagine we had a dog object here, right? See, we had a dog object. Agree? This is an object. Its address you are storing in a variable D. Of what type? D is of dog type. Yes. Whose object you are storing, that type your reference should be. Which means you think and tell me, right? If this is also node type. Yes, this is also node type. Don't you think I have to store the address of one more node type object? That is why next is pointing to a object of node type. This is what I will tell. Yes, inside the class node, inside the class node, you have to again write node. Okay, I hope you're understanding. So your data is a variable which will hold integer type data. Next is a variable which will point to the next object. That object is of node type. Okay, fine. So this is what I have to tell. But if I tell only this much, who will give data? Who will give the next? That's why I have to write a constructor. I'll write a constructor like this. What is a constructor? I'll write here, this is a constructor. Okay. So it's a parameters constructor. I will tell if someone calls a node and if they pass a integer type value, whatever value they have passed, give it to the data. Yes, I will close this class. I hope it is clear. So now, okay, our class node is done. Okay. So now what happens is, where if someone calls node and whatever value they pass, that value will be stored in the data. Okay, that value will be stored in the data. So let's see here. If I tell now, right, this is the class launch. Okay, class launch. In the class launch we have public static void main string of args. Okay, and here now I will tell I want a new memory. Why? I want to create a node now. Okay, and I'll pass the 10 here. As soon as I write like this, what happens is new object, a new node is created. Okay, a new node is created, a new object is created like this. And you told new node of 10. Don't think 10 is passed here. 10 is passed here. Yes, that 10 is going to data. Right, because whenever you create a node, when you tell new node, what will happen? When you tell new memory, it will allocate a memory, but it will go to the class and it will copy all the data into the object. It will go to the node class and it will copy all the details. So this is a object, and inside this object what is there? Whatever is there in the node class, everything will come here. What is there in the node class? You have something called as data. Default value is 0. You have something called as next. Default value is null, because object, it is null. Then you have one constructor, right? So that is node type constructor which accepts an integer type val. Then data is equals to val. Okay, this is what will happen inside a object. Now what you have called? You have called such a constructor which is accepting one integer type. Now that's why this will execute. So that 10 is stored in the val. That 10 is given to data. So this data becomes what now? 10. So you have an object who is storing 10 now. And don't you think this object has an address? Maybe let me tell it as the address is 1000. Don't you think that should be stored somewhere? Yes. That is why what we will tell is like this: whatever new node you have created, okay, whatever new node you have created, I will be storing it in variable first. I will be storing it in variable first of the type node, So now what will happen is, now, okay, what's here? Now first, okay, first is a variable which will contain that 1000 and it will point to this object. First will point to this object. Is it clear? This is done. Now what I want to do is, I want to create one more node, right? I want to create one more node like this. I want to create one more node. So how do I create one more node? Right? By telling like this. Again I am telling I want a new node. I want a new node of 20. I want a new node of 20. As soon as I tell like this, understand? As soon as I tell like this, what happens is, new node, as soon as I tell new node, all the members of the node class will come and paste here. So data will come default value 0, then next will come default value null, then you have node constructor, right, which accepts the integer type val, then whatever is there in the val, it is given to okay. So whatever I give to val, it will give to data. Okay. Now my constructor will run, okay, and I'm calling new node of 20, which means 20 is passed here. That 20 is given to data, and for this object the data becomes 20. Okay, for this object the data becomes 20, and this object also has a starting address 2000. Yes. Okay, let me erase this so that it will be more clear. Okay. Now what should happen? What should happen now? What should happen is, see, using the first variable I can access this object. Using this object I should be able to access this object. Now how do I do that? What is the address here? 2000. Yes, here I have to tell whatever null is there, that should be cutted and 2000 should be stored, so that this object can point where is the next object. If I want this to happen, you think and tell me, don't you think what should happen now is the address of the new node whatever you have created 2000, the address of the new node whatever you have created 2000, where I have to store it? I have to store it in first dot next. Yes, there is a variable called as first. The first is pointing to an object, but inside that object there is a next variable, right? Inside that variable I have to store. So whatever new object I have created, its address, right, its address, what is it? 2000. Should I store that 2000 in the second, something like that? No, store this 2000. Okay, what I have to tell is like this: store this, because by as soon as you tell new node, its address is returned. Where should I store its address 2000? That has to be stored in first dot next. This is what I have to tell. Now what happens is, a new object whatever you have created, where it is stored? In the first dot next, that is like here. Okay, in the first it will do a dot, inside that next, inside that it will store 2000, which means this object, it is pointing to this object. I hope this is clear. Okay, I hope you have understood this. Please take the diagram. Take the diagram. Okay, take this diagram. Only this much. This is a basic program to understand everything. I hope you have paused the screen and taken the diagram. Now you take other diagrams like this. This much is enough. No need to write other things. Okay, so for this program, that is a diagram. I hope you have paused the screen and taken this notes also. And take this class node, right? Take this class node. Right? Okay. So this was the basic understanding, but there is a problem here. This is not efficient, right? Why? Because imagine I want to add one more node. So if I want to add one more node, don't you think I have to tell again new node? new node, I'll tell 30. As soon as I tell like this, immediately what happens is, okay, a new object is created whose data is 30, right, and whose next is by default next is pointing to null. Okay, now this has a address 3000, right? This object has a address 3000. Now don't you think, okay, let me erase this. Okay, now don't you think what should happen is this object should be containing what? Here 3000 should come, so that this will point to this object. This should happen, right? This will point to this object. This should happen. If this has to happen, the new object whatever you have created, its address, it has to be stored inside. It has to be stored inside where? It has to be stored inside next. Agree? It has to be stored inside next, right? So who's next? It has to be stored inside 2000 dot next. Okay, let me see. So 3000 has to be stored inside which object? 2000's object. 2000, inside that 2000 dot next I have to write. Okay, so this new node, it has to be stored where? 2000 dot next. To inside 2000 object, inside that next, this new node you have to do. Is it true or not? Let's see. Yes, inside it, inside 2000th object, inside that there is a next. For that next store 2000. But where will I get to 2000? I will get to 2000. Where will I get 2000? Don't you think 2000 is stored here? Yes, I will get to 2000 where? Inside 1000 dot next. Yes or no? In the 1000 dot next. So I'll write, hey, this 2000 is nothing but 1000 dot next. Okay, so inside 1000 dot next, that is. And where is 1000 stored? Let's see, 1000. Don't you think 1000 is stored in the first? Yes, that is why instead of writing 1000, okay, instead of writing 1000, what you have to write is first. So it is first dot next dot next. Okay, this is how it should be. First dot next dot next. So this will work. But okay, understand, if I have to add one more object, it is first dot next dot next dot next. Again first dot next dot next dot next dot next. So like this I have to keep on going, and programmatically it is not possible. Yes or no? Because what if I want to add 100 elements, then 100 times after dot next like this I have to type that. So that is the problem. Okay, so now you have understood around some 80%. If you want to understand again 10% more, let me revise it again so that you will understand more clearly. Okay, so let me delete all this, because from the beginning I want to create an object. So watch here carefully. Okay. So all this object whatever you are seeing, let me erase them. Okay. Now I will tell I want a new node. Okay, I want a new node, and that should contain 50. I will tell like this. Now what happens as soon as I tell this, a new object is created where data is 50, right? Data is 50, but where it is pointing next, it is not pointing to anything now, because this is the first object. First object means there is no next object, so next is pointing to null. There is no next object, but this object has an address. I'll tell it as 1000. This 1000 I'll be storing it on variable called as first. Okay, so first is a variable which will hold what? 1000, right? It will hold 1000, which means first, okay, is pointing to this object. Done. First is pointing to this object. This object should point to another object. That object should point to another object like this. Okay, this is fine. Now this is done, and I have to store in which variable here? I have to store in first variable like this. Of what type? Of node type. Okay, done. Next is I will tell I want one more new node. I want new node. I want to store 30 like this. So what happens as soon as I tell this, because I told new node, just because I told new node, simply a new object is created. Understand? Till now there is no link at all. There is no link, just a object is created. I have to link it manually later. So this object data part is what? Data part is 30 because of the constructor, direct value is assigned. Okay, then there is a next. This object, is it pointing to anything now? No, it is not pointing. So next is pointing to null. This is done. But this object has address 2000. Now what I have to do? This new object's address I have to store in where? Next. Who's next? 1000 dot next. Inside a 1000 object there is a next. So what I'll tell is the new object whatever you have created, its address has to be stored, right? Its address has to be stored in where? In 1000 dot next. Because when you tell new node, understand this thing, what is returned is the address which is returned. Address is what now? Address is 2000. So that 2000 where am I storing? In 1000 dot next. So in what, this is 1000, right? This is 1000. In 1000 dot next, there I am storing 2000. But what is 1000? Where is 1000 stored? 1000 is stored in the first variable. Yes. So instead of writing 1000, we will write it as what? First. I hope this is clear, right? This is clear. Next, I want to create one more new node. I want to tell 10 here. I want to tell 10. As soon as I tell this, what happens, right? As soon as I tell this, okay, by the way, this will be pointing to this object. Okay, this is done. Now I want to create one more new node. I have told 10. So what's the data part? Data part is 10. And right now this next is pointing to what? This next is pointing to null. But this object has an address 3000. Now 3000, I have to store it where? I have to store it here. 3000 has to be stored here so that this link can happen. 3000 has to be stored in 2000 dot next. Inside 2000 object there is a next variable. So this new object has to be stored in 2000. Okay, 2000 dot next. But where is 2000 stored? Let's see. 2000, where is it stored? 2000 is stored where? Where is 2000 stored? In 1000 dot next. Where is 2000 stored? 2000 is stored in 1000 dot next. So I'll tell 2000 is stored in 1000 dot next. Where is 1000 stored? 1000 is stored in first. So first dot next if I tell, yes, that linking will happen now. Okay. Now for the last time, let me add one more new node. Okay, let me add one more new node where I'll tell it is 20. So now what happens is a new node is created with the data, okay, with the data 20. Okay, with the data 20. New node is created with the data 20. Now this has a next, right? This has a next here. Next is there. Next, by default it is null. By default it is null. Okay. Now this object has an address 4000. I will tell 4000 has to be stored here. 4000 has to be stored here so that this object 3000, it knows what is the next object. Next object is 4000 like this. Okay. So how can I make that happen? Whatever new object you have created, its address has to be stored in 3000 dot next. Okay, so here we'll tell it is 3000 dot next. This is what we'll tell. Where is 3000 stored? Okay, 3000, where it is stored? 3000 is stored in 2000 dot next. 3000 is nothing but 2000 dot next. Where is 2000 stored? 2000 is stored in 1000 dot next. Yes or no? See, watch here. 2000, where it is stored? In 1000 dot next. Okay. Then where is 1000 stored? 1000 is stored in first. So 1 next here, 2 next here, 3 next. Next is 4 next, like that. So I hope you have understood. Okay. So after all this program, don't you think your node will look like this? Yes. So all the next, whatever next is pointing, next. But the last next is pointing to null, which means it is not pointing to any other object. It is stopping here. Okay, so this is how your node will look like. Okay, so I hope you have understood. If you want, you can take this diagram if you want and take this code, and yes, this is the same class node. Okay, this is how it is. Okay, now let me tell you that how to read this, right? How to read this, let me tell you. Okay, let me store as it is. Now there is no problem because now I am not worried about how to store efficiently. Now I am worried about how to read. Now we have understood how to store data. Let's read the data, right? Let's read the data. And what's the logic to read the data here? First of all, I should have from where I have to start. Okay, I have to start from the first. What I'll do is I'll print first dot data. What I'll do, okay, I will give the first value, okay, first dot data. What is first dot data? 1000 dot data is 50. It will print 50. After printing 50, I have to print 30. I have to print 30. Then what to do? Okay, watch here carefully. Watch here carefully. What I'll do? What I'll do is, okay, I will write a while loop. Okay, I'll write a while loop. Watch here. Before starting the while loop, first of all, I'll tell, hey, see inside this while loop, what's the condition? We'll see later. But inside this while loop, what is there? Inside the while loop, system.out.print temp dot data. This is what is there. Okay, what I have to print? We have to print temp dot data, which means, okay, if you want to print any object data, then temp dot data you have to tell. Now what I have to tell is whatever is there in the first, okay, whatever is there in the first, that first value you give it to temp of what type? Of node type. This is what you have to tell. What's the first value now? First value is 1000. So don't you think I am tracing it now? Watch here, I am tracing it now. Now let me take a different color. Okay, so temp is a memory, okay, which is containing what now? It is containing the first value. What's the first value? 1000. So temp will contain 1000. Okay, what I have to check here is I have to check something. We'll see that later what it is. So I want to keep on, this while loop to execute. What is temp dot data? Temp dot data means 1000 dot data. So temp value is 1000. No, what is 1000 dot data? 50, right? So I'll have my output screen here. Okay, I will have my output screen. Output screen, what is the answer? 50 is the first answer. Okay, after printing 50, don't you think I have to print 30? Yes, if I have to print 30, I have to tell 2000 dot data. So if I have to print next value, see, next value I have to print 30, right? Clearly after 50 comes 30. If I have to print 30, where is 30 stored? 30 is stored in 2000 dot data. Yes or no? In 2000 dot data. So somehow I have to print 2000 dot data, which means somehow your temp should become 2000. Yes or no? And how can your temp become 2000? Let's see that. Okay. Now what I have to tell here, if temp has to become 2000, see, when my temp is 1000, how can I get to 2000? Yes, from here, from here only 2000 is there. So that is why I will tell like this, my new temp value is old temp value. Okay, right now what's the temp value? 1000. Yes, and I want to get this I want to store this 2000 inside the temp. In that case, temp dot next I will tell. My new temp should point to the next temp, like this. This is what I'll tell. Now what happens is, watch here. Right now temp value is 1000. So what is 1000 dot next? Can you tell me what is 1000 dot next? 1000 dot next is 2000. That 2000, where am I storing? In the temp. So now don't you think temp becomes 2000? Yes. Okay. If temp becomes 2000, I have to check one condition. Hey, is a temp, okay, I should tell if it is 2000, continue. If it is 3000, continue. What's the meaning of 3000? 3000 means next object is there, continue. If it is 4000, continue. But if it is null means what? Next object is not there, stop. That's how I have to tell. If temp, if it is not equal to null, then only do all this procedure. Okay, this is what we'll do. Now temp value is what? 2000. Is 2000, is it not equal to null? Yes, 2000 is not equal to null. Condition is true. If the condition is true, it will come inside, and now what it will print? Now it will print 2000 dot data. It will print temp dot data, and temp value is 2000. So 2000 dot data. What is 2000 dot data? 30. So it will print 30 now. What it will print? 30. After printing 30, I want to print 10. But if I have to print 10, what I have to print? Okay, right now the temp value is 2000. Okay. If I have to print 10, I have to print what? 3000 dot data. But where is 3000 stored? It is stored here. So I have to tell, right now the temp value is like this, right? Right now the temp value is 2000. I have to tell my new temp value is 2000 dot next. What is the temp value now? 2000. What is 2000 dot next? In the 2000 there is a next, that is 3000. That 3000 you are storing in temp, right? That is why this temp becomes 3000 like this. After it becomes 3000, it will check the condition. Yes, 3000 is not equal to null. Condition is true. 3000 is not equal to null. It will print temp.data. What is the temp value? 3000. What is 3000 dot data? 10. It will print that 10. After printing that 10, you are telling the new temp value is old temp value dot next. What is the old temp value? 3000. What is 3000 dot next? 3000 dot next is 4000. 4000 is stored in temp, so temp becomes 4000. Temp becomes 4000. It will check the condition. Is 4000, is it not equal to null? Yes, 4000 is not equal to null. Condition is true. What is 4000 dot data? Temp dot data. Temp value is 4000. What is 4000 dot data? 20. So it will print that 20. After it prints 20, what we are doing? Temp dot next. What is the temp value now? 4000. So what is 4000 dot next? 4000 dot next. What is 4000 dot next? In the 4000, what is the next value? Null. Null is given to temp. So temp will contain what now? Null. It will contain null. Then when you check the while loop, what is the temp value? Null now. Is null not equal to null? A condition is false. Null is equal to null. But I am checking the condition. Null is not equal to null. Condition is false. Control will come out. Agree or not? Control will come out. Now don't you think I have printed 50, 30, 10, 20? Yes. Okay. So this is that program. I hope you have understood here. Okay. So now let me write the program for this. Okay. Let me create a new Java class. This Java class, I will name it as node. Okay. What's the meaning of red color? Red color means inbuilt class is there, but I don't care now. Okay, it's okay. You can write node, no problem. Okay, but okay, let me write class launch. Okay, class launch, and there is a class node. I have an option. I can create a separate file for a class node, or I can write in this class only. Anything is fine. Class node, I will tell. In this class node, right, I have a integer type data which I want to store, and node type next value. This is these two I want to store, but I should have a constructor. So node type which accepts integer type val. Okay, whatever it accepts data is equal to val. Okay, constructor is done. This is the node. So now here we will tell I want to create objects. So first I'll tell I want a new node. It accepts what? 10. Whatever new object is created, this is the first object, so I'll store it in first of the type node. Then I will tell the same thing for the 20, but this reference will be stored in first dot next. According to us, it is 50, 30, 40, 10, or was it 50, 30, 10, 20? Okay, 50, 30, 10, 20. Okay, but it is first dot next, then it is copy, next. Okay, so this is how it is. Definitely that structure will be there. Now how do I know, right? I can't see visually that structure is there. I can only know by the way we print. So I will tell I want a new temp, I want a new variable temp. Initially it should hold the first st. Okay, like this. Now what I'll tell is while temp is not equals to null. Initially, so first value is 1000, right? So 1000 is given to temp. Yes, what will temp contain now? 1000. 1000 is not equal to null. Okay, 1000 is not equal to null. In that case, system.out.println. Okay, what I have to print? Print that temp.data. As soon as you print temp.data, you have to go next. That's why the new temp value is old temp value, right? Dot next I will tell like this. So that's it. Now let's see. I will compile, launch like this. Okay, so let me tell it as launch h with extra h, so extra h. Okay, I have executed. So 50, 30, 10, 20, we got the output. Okay, we got the output. So yes, you can take notes of this. Okay, yes, you can take notes of this. So this is the way to traverse through a string. Okay, I hope you have understood the basics of the nodes here and how to traverse through a string, and how do I. Now the question you might be having is, why have you given the first value to temp and so on? See, why? Because if I could have operated on first only, but if I do that, now don't you think here temp value is changing? Yes, temp value initially it was 1000, right? Then it became 2000, it became 3000, it became 4000. Finally temp became null. If I do the same operation on the first variable, first will be what? 1000, then first will change to 2000, first will change to 3000, and so on. Okay, so the problem will be that there will be, if first changes, then how will I get to know where is the first object present? There should be a variable which is still pointing to the first. Okay, because in the future I want that, right? I want this variable which is very, very, very important. So wherever the first object is pointing, that reference, I have to store it somewhere very, very safe. That should not change. I hope that point is very clear for you. That is why I know that if I use a while loop, if I use a temp is equal temp.next, I know that temp variable will keep on changing, right? Yes, if I know it will change, why should I change the only variable, right? First is the only one variable which is pointing to the first object. I should not lose that reference. I hope it is clear. That is why I am taking a copy of that. Then I am changing the copy. Okay, I am changing the copy here. I am not changing the original one. First is still pointing here, but temp is the one which is keep on changing its pointing. Okay, so I hope your some doubts are clear now, and I hope your notes also you have taken. This is the basics of our node. Now what we'll do is like this. Okay, let me take a new page so that it will be very much neater here. So now in this example, what I want to do is I want to delete the node number 10. Okay, so this node I want to delete. If I want to delete the node, what should I do? What I have to do is I have to break this connection, and I have to break this connection, and directly I have to connect like this. That's it. Deleting means in this way only, because when you break the connection, you think and tell me, does this object is its reference stored in any variable? No. So garbage collector will collect that. Okay, so object is deleted by default. So you just have to cut the connection. Means, okay, what we have to tell now is that only one thing you have to do, that is this object, right? If you want to delete 10, remember, if you want to delete 10, 10's previous object should be connected to the 10's next object. Agree or not? 10's previous object should be connected to 10's next object. As simple as that. Only that we have to do. So how do we do that? That we have to think, okay, how to connect 10's previous object with 10's next object. Because if I connect, that's it. Okay, if I connect, that's it. This link will automatically break. Okay, this link will automatically break. How it will automatically break is like this. Watch here. Okay, now we have this diagram. Now what you have to do is, definitely you need 2 pointers now, right? You need 2 pointers. Okay, that is, you need a pointer where it will point to the current node C and previous node P, right? You need 2 pointers like this. Okay, you need 2 pointers. Now why I need 2 pointers? Because using the C, okay, using the C, I can get to know if this is my current pointer. I know the next address is 4000, I know that. But you think and tell me, once you come, imagine you had only one pointer. If you had only one pointer, imagine temp is a pointer which is pointing to this object. Using temp, you can get to know temp's address. Temp's address is 3000. You can get to know temp's next address. Temp's next address is stored here, 4000. But can you know temp's previous address? No. I hope you are understanding the point here, okay? Which means if you have any node, now temp is pointing to what? 3000. Temp is pointing to 3000. So if temp is pointing to 3000, the current node I know. What's the current node? 3000. I know the next node also, 4000. Where it is stored? Temp's next 4000 is stored. But where is temp's previous stored? It is not stored anywhere. That is why we should have one more variable, previous, which will update. That's it. Okay. So this is the logic which I have to use. So now how do we do it? Let's see how do we do it. So now what I will start with is, I will start P with null. And I will start current. I will start current with the 1000. Okay, because the first object is what? The first object is 1000. But for 1000, for this object, is there any previous object? No. No means that's the reason I have taken as null. So now, right, now what you have to do? See, one thing I want you to understand. Okay, that is, if there is object, then only there is a data. Agree or not? Okay. So for example, remember you have written first, right? Can you tell first dot data? You can tell first dot data because in the first there is a data here, right? First there is a data. But imagine if your first is pointing to null, and if first is pointing to null, you can't tell null dot data. This is null pointer exception. Is it clear? This is null pointer exception. Please understand, if you want any variable, if you want any attribute, you can't tell using a null pointer. Okay, first is pointing to null, that's the reason you get null pointer. But right now it is not pointing to null. That's why we have to check every time. I will show you the code. See here, can you see that we are accessing temp.data? Yes, but please understand, before accessing temp.data, we are just making sure that temp is not equal to null. If temp is not equal to null, then only we can access the data. If temp is equal to null, we'll get a null pointer exception. Okay, we'll get a null pointer exception. Because on a null object, you can't tell any dot operator. That's it. Okay. So here, first P should be null and C should be 1000. Now I want to check, right? What I want to check, that whether 1000, I want to delete 10. So what's the thing? Delete node containing 10. Okay. So is 1000 dot data 10 or not? I have to check. Okay, is 1000 dot data, is it equal to 10? I have to check. No, it is not equal to 10. If it is not equal to 10, I have to move to the next. Agree or not? I have to move to the next. That means C was pointing here, now C should point here. Agree? If C has to point here, don't you think P has to point here? Yes, P has to point here. Means P has to point what now? 1000. And now don't you think this 1000 value, it has to go to the P first? Yes, it has to go to the P. After it goes to the P, your P will become what? 1000. After your P becomes 1000, then you have to update your C value. You have to update your C value to 2000. I hope it is clear. Okay, you have to update your C later. Why you are thinking? Okay, I know. Let's see. Imagine this was my first case, right? Now you are thinking that first let me update this. Please understand, if you update this first, 1000 become 2000. How will you update P? How will you update? It is not easy to update P now, right? Yes, that is why before updating C, whatever 1000 you have, you first store it in P. First store it in P like this. After that you tell this C value is C value dot next you tell. Like this you have to tell. Why? Because what is this? This is what we have to write. Okay, this is what you have to write. First give the c value to p, then the new c value is old c value dot next. What is the old c value? 1000. What is 1000 dot next? 1000 dot next. What is in the 1000? What is the next? 2000. That 2000 I am storing in c. Okay, I hope it is clear. Okay, I hope it is clear. So let me delete this. Let me create two variables, that is p and c. Okay, so p was containing null in the beginning, c was containing 1000, which means c was also pointing to this. C was also pointing to this. But we know that there is one line here which is very important. What is that line? First c value should be given to p. What is the c value? 1000. 1000 is given to p, so p will become what? 1000. And which means p is also for momentarily pointing to this object. P is also pointing to this object. Then you are telling, okay, once p is attaching to whatever I am attaching, c will update. Now the new c value is old c value dot next. What's the old c value? Right now the c value is 1000. What is 1000 dot next? 1000 dot next. In the 1000, what is the next here? 2000. So 2000 is stored where? In the c. So your c will become what? 2000. I hope this is clear, which means now your c is pointing to the 2000. Please understand, this is what is happening. Now wherever it is pointing, I have to check, hey, if this is c, wherever c is pointing, whether this c dot data is it equal to 10. This is what I have to check. Okay, is c dot data is it equal to 10? No, c dot data is 30. No, it is not, right? Then in that case, if this condition is false, I have to do this now. So whatever is in the c value, I have to give it to p. What is in the c value? 2000. 2000 has to be given to p, which means now p is pointing to 2000 object. P is pointing to 2000 object. Okay, so since p is pointing to that, now c should update. Agree or not? C should update. So how will c update? C, what is the c value now? C value is 2000 dot next. What is in the 2000? What's the next address? 3000. That 3000 where am I storing? In c, right? In c. So c will contain what? 3000, which means this is pointing, this c is pointing to this object now. Okay, it is pointing to this object. I hope it is clear. After, as soon as it points to this object, I'll check the condition again. Wherever c is pointing, right? Okay, I'll check the while condition like this. While, okay, wherever c is pointing, that c, okay, should not be equals to what? It should not be equals to null. Because if it is not equal to null, then only I can check, hey, if c dot data, right, is it equal to 10? Yes, I have told you very clearly, whenever you are accessing anything dot data, make sure that anything is there, no, that is not equal to null, then only you can do it. So make sure that c is not equal to null here. If it is not equal to null, then only you can access the data. If it is null, you can't access the data. That's why if c is not equal to null, then check c dot data. Is it equal to 10? Right now, don't you think c dot data is equal to 10? Yes, c dot data is equal to 10. In that case, I have to perform some operation, then I have to break out of here. What operation I have to perform is, okay, I have something right here. Now what is my end result? Let me write it in a different color. My end result I will write in white color. The end result is this should connect to this. Connection means what? The address of 4000, right? It should be stored here. Okay, the 4000 should be stored here so that this object knows where to point. Tell me, 4000 is stored there, 3000 is cutted by default because only one address can be stored. Yes, so 3000 is cutted and 4000 is placed. If 3000 is cutted, it doesn't point to 3000 anymore. Yes or no? It doesn't point to 3000 anymore. Agree? It points to what now? It points to 4000 like this. So this is what I want to happen. Okay, now I want to store 4000 where? Let me write it. I want to store 4000. Where I want to store 4000? I want to store 4000 in p dot, p is pointing here, right? P is pointing here. In p dot next I want to store. Agree or not? Yes. In I want to store 4000. Okay, leave p, forget p. Where I want to store 4000? 4000 has to be stored in 2000 dot next. Yes, 2000 dot next. You write like this only first. So 4000 has to be stored in 2000 dot next. Yes. Now where is 4000 stored? Don't you think 4000 is stored? 4000 is stored in 3000 dot next. Agree or not? 4000 is nothing but what? 4000 where it is stored? 4000 is stored in 3000 dot next. Okay. Now what is 2000 in the memory? 2000 is nothing but p. So erase, you write p. What is 3000? 3000 is nothing but c. Erase this, write c. I hope it is clear, right? C dot next. C dot next. Okay. So done, right? It is done. It is done. This is it. Okay. This is what I have to tell. When I have to tell, if the data is found, then only do this. If data is not there, then for this if there is one else part, right? That I have to tell. That else part I have to tell like this. If the data is found, then take the next, connect it. If the data is not found, then move your c, move your p, move your c, move your p. Keep on changing your c and p and find the data. So I hope you understood the logic. Okay. If you want, you can take this diagram. I will pause. You can pause the screen here. Okay. So now whatever you have understood, let's try to write a code. Now can you think and tell me, this node is used to print all the elements? Agree or not? This code is to print the node elements. That's why let me create what? Let me create the method for this. Let me create a method for this. So I'll cut it and I'll tell print. Okay, I'll undo this. Okay, I'll cut it. I'll tell print what? Print temp. Okay, print temp means whatever node you pass, from that node till the end node it will print. So I'm telling print temp. Okay, print node. Okay, print node. Which node? Temp. So print node is a method. Okay, print node is a method. Let me write here. Print node is a method. This print node, okay, I'll make it as a static. Why? Because from a static method, if you call a method without a dot operator, then that method is also static. This is the basic concept. Then am I collecting anything from print node? No, I'm not collecting anything from print node. Return type is void. Print node, you are passing something, you are passing temp. That temp is of what type? Node type. So it accepts one node type temp. And now we will paste whatever you have done. So I'm passing something, whatever it's accepting, it is printing that. So let's execute this program for now. I'll compile and I'll execute. I got all the array elements. Okay. So now what I will do is, this is the main method, right? This is the main method. Before printing the temp, right? Before printing the temp, I want to do something. What I want to do? Let's see. Okay. Before printing all the content, this program I want to run. While c is not equal to null, right? Yes. So I have to start with what? I hope you remember we have started with the p is equal to null and c is equal to 1000. We have started from here. And 1000 is nothing but first value. Yes or no? Yes. From here we have to start. I have to tell node p is null. Okay. Node c is first. Like this I have to tell. So after this, what I have to do is I have to write a loop. While loop, while c is not equals to null, then check if c dot data is it equal to 10. If it is equal to 10, what to do later we'll see. Else part, if it is not equal to 10, okay, then the previous should be current one, and the current should go to the next. Yes or no? Current should go to the next, like this. This is what I will tell in the else part. And in the if part, we have seen, in the if part it is like this, p dot next should be pointing to c dot next. Okay, so what will this program do? This program, it will search for 10, and whenever it search for 10, whenever it finds 10, it will connect and it will lose the 10. After losing the 10, then I am telling print the, okay, now this temp, I'll cut it and I will tell it here like this. Okay, now I'll compile, right? Watch here, I'll compile, right? And if I execute, it is an infinite loop. And why I'm getting infinite loop, I have written this code, like we can trace why it's an infinite loop. I am printing c dot data, right? So we got to know that it's an infinite loop. Why? Because it'll, okay, let me execute again. So let's see the value, 50, 30, right? But 10, 10, 10, 10, 10. Do you remember I had told you we have to break? Yes, as soon as you cut the connection, right? If you find your 10, you told what? Cut it and you have joined, right? You have joined. As soon as you join, what you have to do is you have to write a break statement. Agree? You have to write a break statement. So now I'll break, and as you can see, yes, the thing is we are printing something which is like this, we have to remove that. Okay, unnecessary printing we are doing. So now 50, 30, 20. So we have cutted what now? 20. I hope it is clear. Okay, this program is clear. So that's it. So this program, okay, we need a previous value, we need a current value. So let me trace it to you guys again so that you guys will understand. Okay, so imagine that this is the node. I have already revised about how to print all the elements, right? So what should happen is, first temp should point here, print temp dot data provided temp is not equal to null. Is temp pointing to null? No, temp is pointing to an object, right? Then update your temp by telling temp is equals to temp dot next. Okay, temp will come here. Print temp dot data provided temp is not equal to null. So we can write like this, while temp, if it is not equal to null, then only SOP, okay, then only SOP temp dot data. Yes, then new temp is equals to old temp dot next. We have already seen this, so that's why I will not go through that. So now we are not printing simply the elements of an list. Now I want to search, so I need a C value and P value. So what I need is, I want to remove the node which is containing 10. So if I want to delete this node, right, if I want to delete the node, what I want to tell is this connection, right, this connection should happen, right, this should be lost, this connection should happen. So if I want to do this, if this object has to point to the object number 4000, right, see, previously this connection was there. What? So what's the meaning of 3000? 3000 means whatever number is there, for that location it will go next. Now I don't want it to go to 3000, I want it to go to what? 4000, means it will point to this object, which means 4000 should come in this location, yes or no? So 3000, whatever it was there, okay, whatever 3000 was there, it should be cutted, and in that location here 4000 should come and sit in that. Okay, that we have understood, which means I have to keep on searching. Okay, is this number 10? Is this number 10? Like this. And when I find a number 10, if the current pointer, C means current pointer, if the current pointer is 10, right, current pointer's data is 10, because right now C value is 3000, means it is containing 3000. Is 3000 dot data, is it 10? Yes. If it is 10, then C's next whatever is there, that address should be pointed here. So how do we do this? If I want to do this, if I have a C value, I have the current node and I have the address of next node also. Here, see, 3000 dot next. If I tell, I'll get the next node. But do I have the previous node? No. That's the reason I should have two variables which will keep on holding the previous node like this. Okay, like that. Okay, so when my C value is here, my P should be here. When my C value increments to here, my P should come here, like this. I hope you are understanding. Which means initially my C should be pointing to what? C should be pointing to 1000. That is the first node, that's why. And the previous should be pointing to null because there is no node before the first. After this, the C value is here, right? Is this C value, is C dot data, is it equal to 10? No. No means what should happen? First P should come here, then your C should increment. Agree? Which means wherever C is pointing, the same 1000 value your P also should contain, like this. So first I have to tell, okay, first of all I have to ask in the while loop. In the while loop I have to ask, okay, condition we'll see later. First I have to ask the question, is C dot data, is the current data, is it equal to 10? If it is equal to 10, then do something for the else part. If it is not equal to 10, right now it is not equal to 10, then whatever C value is there, give it to P. I'll tell. What's the C value? 1000. 1000 is given to P. Okay. So previous I have updated. Then my new current value is old current value dot next. What happens in this line? I have already traced it and told it to you. You just have to understand C will move to the next element. If I am checking C dot data, do remember you should always check C is not equal to null. That's it. Okay. Now, so now I have updated, right? This update has executed. Again, to check the condition. What's the C value now? C value is 2000. Okay, C value is what? 2000. Is 2000 not equal to null? Yes, 2000 is not equal to null. What is 2000 dot data? 2000 dot data is 30. Is 30, is it equal to 10? No. No means else part will execute. Whatever is the C value is given to P. What is the C value? 2000. 2000 is what? Given to P. Which means, 2000 is given to P like this here. Which means your P, right now your C is also here, P is also here. Okay. But I am telling the C should go next, I am telling. So C will move here. As soon as C moves, nothing else is there. It will check the while condition. Is C not equal to null? Yes. C is containing what now? The next, that is 3000. 3000 is not equal to null. Then if 3000 is not equal to null, it will check 3000 dot data. What is 3000 dot data? 10. Is 10 equals to 10? Yes. Yes means what should happen? What should happen is 4000 should come here. Agree or not? Yes. 4000 should come here. 4000, let me write here, 4000, okay, should come where, right? Here means where? 4000 should come in 2000 dot next. 4000 should come in 2000 dot next location. So 2000 dot next location I will tell. Where is 2000? Can you see 2000 is nothing but P? So let me write 2000 is nothing but P. Where is 4000 stored? 4000 is stored here. Yes, 4000 is nothing but 3000 dot next is 4000. So 3000 dot next I will tell. And where is 3000 stored? It is stored in C. So I'll delete this 3000. I'll write C dot next. And you know that you have to write a break as soon as we find our answer. So that's it. Okay, I have explained again. So I hope second time when I explained, more people understood, had you got more clarity here. Okay. So now again the thing what we have to do, the thing is we can't write in this way. Okay, we can't write in this way. We have to create a method for that because each of them is a different functionality, right? Printing is a functionality, it's a one process, and deleting something is one more process. That is why what I'll do is I'll create a method called as delete node. Print node is over. Okay, delete node I will tell. So how we can improve this is, why should I create a node here? Okay, what I'll tell is like this. Okay, this is all what do you say, programming techniques here. I will directly give what? First, I'll directly give first node. I'll directly give first node. But here, okay, what will happen? Tell me, is this a same variable of the first? No. First is a local variable, right? First is a local variable from here. First is a local variable from here. Agree? And temp is a local variable from here. Even though your temp is updating, right? Your temp is updating. Will it reflect the local variable which is in the main method? No. Main method's variables are different. Print node variables are different. So there will be no changes here. I will execute. So I hope you understood. We can give that. So all this functionality I will cut, right? I will cut it and I will tell, okay, if you want to print, right, what is that? Delete, right? Delete what? Delete node. Delete node. Which node you want to delete? I want you to delete 10. So delete node is a method. Delete node is a method which is static, which returns void type. As of now, let's imagine void, and it accepts an integer. So it accepts an integer type val. Now I'll paste the code and I will tell, okay. Okay. Now is not equal to 10, right? It is equal to val. Yes, everything is same, but p is equal to null. How can I tell c is equal to first, right? How can I tell c is equal to first here? Because first you tell me, is it a local variable? No. Is it a global variable? No. I have one option. I can pass like this, right? I can pass two variables, that is int first and int val and node first. I can tell like this. And here I have to pass, you have to delete node, right? 10 from first. So what is this first? First is a reference to the linked list. So I have to tell which linked list, from which linked list, what element you want to delete. Okay, I am telling that what element you want to delete from which linked list, like that. So here also the same thing, you know, in the method signature also I am accepting two numbers, two items. First one is a number, second one is a address to the first node. That's it. So I'll compile. Okay, what is that? Expected semicolon. Okay. Now let's see what is the problem. 50, 30, 20. We got the answer, right? So I hope it is clear here, okay, about delete node, print node and all. So basics you have understood, right? Somewhat basics you have understood. Now see, it's very easy. Nothing is there. You just actually, you have to imagine. You have to imagine there is a node. You have to imagine there is a node, and you have to understand that each node has the value and where it is pointing. So it's all about how to cut this connection and how to rejoin the connection. That's it. Okay. Now, if I want to make it like more industry level, what do you say, program, then the thing is, you think and tell me, don't you think delete node is a method which should have been inside a node class? For example, if I tell bark, bark is a method which is present in dog class, right? Because dog will bark. So that's the reason you have to write the appropriate method inside appropriate class only. So let me write here this delete node and print node. These are the methods. I will cut it. I will cut it from here. These are the methods which are present in the node class. I will write like this. And what I will do is, I will make it as, yes, I can make it as static, no problem. I can make it as static. If I make it as static, when I am calling these methods, right, I hope you know static methods can be called using class name. For this static method print node, static method, what's the class name? Node. So I can call here like this, node dot print node and node dot delete node, right? Because using the class name you can call, and I'll have no changes. Okay, so delete node of 10, right? Now watch here, I will again tell delete node of 20, right? So from which node? From the first node. Okay, So watch here. So 20 also deleted. So I hope you have understood here. So it's easy now. It's very easy because we are creating methods, that's the reason. Okay. But I don't want it as a static. Okay, I don't want it as a static. I will remove this static. Now if it is not static, then how do you call these methods? You have to call these methods by the what? You have to call these methods by the object name. And which is the object here? Don't you think first is a object of node type? That's why I'll tell from the first delete node and from the first print node, like this. This is what I will tell. Okay, this is what I will tell. 50, 30 and 20. 50, 30 and 20. Now let me tell you one programming concept here. Okay, see, can you see that using the first, I'm using a dot operator. First dot I'm telling. Yes, and don't you think I'm passing the first also? Watch here, you don't have to pass the first here. Okay, you don't have to pass the first. There is a keyword called as this. So this video for the next 1 minute or 2 minutes is only for those people who already know basics of Java. Okay, so watch here. If you don't know, don't worry, this is not that important, but this is an extra knowledge. So watch here. You are passing first, right? So actually you are two times you are passing some information. You are telling go to the first object, inside that first object print node you are telling, and again you are passing first. Yes, what I can tell is I can simply tell print node. What I have to tell now? What's the meaning of this? A first node is there, no? You print that node I am telling, which means print node is a method. Are you passing anything? No. So here print node is a method where I should not accept anything. I should not accept anything. Then what is this temp? I'll tell that temp is nothing but, okay, that temp is nothing but a local variable of node type. Definitely. Normally you should tell temp is equals to first, right? But now what I'll tell, okay, temp is equals to, please understand, don't you think the first code was temp is equal to first, but first is nothing but this. This is a keyword. It means that what is this, Can you see first? What for this print node method, previous of this print node method, previous of the print node method, what is that? First is there. So this is replaced by what? First. I hope it is clear. Okay, if you write the program like this, if you write this is a keyword, what this will do? This keyword, this keyword is deleted, and what is placed inside of that? This is placed. Okay, the first is placed like this. Imagine if I had written this. Okay, if I had written this, and if you tell here, okay, if you tell here India dot print node, actually it is not possible, right? Because you did not create an object called as India. You created object called as first, but I am giving an example. If we had created object called as India, then if you tell print node, and inside the print node, whenever there is a this keyword, what will happen? This keyword means this keyword is deleted and is replaced by something. It will ask the question, what's the meaning of this? Who called this method is the question. What's the meaning of this? Actually the original meaning is something else, but for you to understand I am explaining in this way. Okay, so what will this do? This means who called this method? Who called this method? Who called print node method? Print node method is called by India. That's why this is deleted and India is placed like this. I want you to understand that. So now, okay, here we have this. This is what we have. Okay, and what is there here? First. Now what will happen is when the control comes here, it will check first. Okay, there is a this keyword. Means who called this method? Who called the print node method? Who called the print node method? Print node method is called by the first of FIRST. So this will get deleted and FIRST is called. And if it is called, this is the first program which we had written, right? 1000 is given to temp. So 1000 is not equal to print 1000 dot data. 1000 becomes 2000 like this. So I'll make it as this, and yes, everything is correct. I will compile, okay, and I will execute. I got the same output. Now one more is there, right? However, you are passing this here. Why you have to pass first? Delete that first. Delete that first. Pass only the 10. Pass only the 10. Okay. So here what I have to tell? Pass only 10. It accepts only 10. Now wherever first is there, I have to tell this now. Agree? So now what happens? P is equal to null, C is equal to this. What will come and replace here? What will come and replace? What will come and sit in this place? Okay, whenever this comes, it will ask who called this method. Delete node was called by first. So this first is copied. It is copied from here and it is pasted in this location like this. Yes, this is what we had in the beginning. So I hope you are understanding, right? This keyword, what use it is. So I'll compile and I will execute. I got the same output. So I hope in this program you have understood what is the use of this keyword. Okay, this keyword, this will replace who called, which object called that method. It will be replacing that. Okay, so now as you can see, my main method is very simple. My main method is short, right? I'm creating a node, deleting a node, printing a node, and all the operation is happening inside this class node. Okay, so this is the topic for today. Tomorrow we will see more node object classes. Okay, we will see more node, that is how do we neatly how do I add each element, because to add, right now I have taken 30, I have taken 50, 30, 10, I have to write like this, first dot, next dot, next dot, next, and so on. Okay, but tomorrow what we'll see is how do we do something where you have to tell, first we have to create a node, right? We will create a node by telling node n is equals to new node. We will create something like this. We will create a node. Then we will tell n dot add, n dot add of what? Add of 10. Tomorrow we will see like this. And we will tell n dot add of 20. So this add method we will start writing from the scratch so that we can write this program. Then n dot add first also tomorrow we will see. Add first 30, 50, something like this. So we will see all this tomorrow. I hope that you have understood this video. If you are not understood, make sure that you are watching this video again. Okay, make sure you watch the video again. So this is the second day of the demo class. So I have decided that tomorrow will be the third day. Okay, but for the third day you should already pay the fees and join the tomorrow's class. Okay, so thank you for watching this video. If you have any doubt, do ask it in the group. Thank you.